We're going to continue on talking about sequences. This is part 3. So our objectives are to find partial sums for a sequence and to find the sum of a finite series. So first we'll talk about partial sums. So a partial sum is the sum of a finite number of consecutive terms starting with the first term. Okay, and there's some notation to see here. So if you were asked to find the partial sum of the first 3 terms, you would see that as S3. So this capital S is denoting partial sum. And this 3 means of the first 3 terms. Okay. So sometimes what you have to do in order to find partial sums is you have to continue the pattern of what's given to you. So let's take a look. So find the indicated partial sums for the sequence. So we're asked to find S4 and S8. So that means the partial sum of the first 4 terms. And the first 8 terms. So I have the sequence 1, 1, 2, 3, 5, 8, 13, and so on. This is actually the Fibonacci sequence, which is pretty cool. Shows up in different places in nature, and it's also where we get the golden ratio from. I've heard, I'm not a decorator, but I've heard that the golden ratio is helpful in decorating and learning where to space things out on walls and things like that. So I just wanted to throw this one in here. So for S sub 4, we are finding the sum of the first 4 terms. So that's 1 plus 1 plus 2 plus 3. So the first 4. So that would give us 5, 6, 7. So S sub 4 is equal to 7. Okay. The next one we're asked to find is S sub 8, which is the first 8 terms. So we're given 1, 2, 3, 4, 5, 6, 7. So we have to find the next term. The pattern here is you add the previous 2 terms. So for instance, 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 5 is 8. 5 plus 8 is 13. So the next term is given by 13 plus 8, which is 21. So the first 8 terms are 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus 13 plus 21. Okay, and you can work this out. You can plug it into your calculator, but this should give us 54. Let me just double check that. Yep, 54. So S sub 8 is equal to 54. Next, we're going to talk about finding sums in sigma notation. So notation, this is capital sigma. It's a way to find the sum when the general term is given. And so the goal here is to add up the ordered set of terms. But what this notation is telling us is, unlike before where it's giving us the terms, this notation will allow us to find the terms that we're supposed to be adding up. So for example, we have sigma, k goes from 1 to 4 of 2k plus 1. So let's talk about what all these things mean. So k is our index, so this matches the letter that's inside. We start at 1, and then we end at 4. Okay, so k equals 1 is our first term, then we go k2, k3, k is 4, and then we stop at k equals 4. And then inside is our formula for the general term. Okay, so by substituting k as 1, we'll get the first term. By substituting k as 2, we'll get the second term, and so on and so forth. Okay, so the way that this reads is we're finding the sum as k goes from 1 to 4 of 2k plus 1. So let's take a look at a couple of examples. So first, evaluate the sum. So we have the sum going from k is 0 to 4 of 10 to the power of k. So we have to find all of our terms and then add them up. So for k equals 0, we have 10 to the 0 power. Anything to the 0 power is 1. And we have k equals 1. So we have 10 to the first, which is just 10. And then we have k is 2, so 10 to the second, which is 100. Okay, and we're adding these up. That's what the sigma means, that we're adding all of these up. Okay, so k is 3 is 10 to the third, which is 1,000. And k equals 4, and this is where we stop. This k is 0 is where we started. 10 to the fourth, which is 10,000. Okay, so we add all those up, so you can add them up by hand or put it in your calculator or do one and then check with the other, and we should get 11,111. So that would be the sum as k goes from 0 to 4 of 10 to the power of k. Next, We have evaluate the sum, so we have k going from 3 to 10 of -1 to the power of k plus 1 times 2k. So we start with k is equal to 3. Okay, so I'm going to do so for k equals 3, we get -1 to the power of 3 plus 1 times 2 times 3. Okay, so -1 to the 4th is going to be 1 times 6, which is just 6. And then we keep going. Okay, and I'm using what we talked about. -1 to an even power is 1. -1 to an odd power is odd. So we have -1 to the 4 plus 1 times 2 times 4, which is going to give us -1 times 8, which is -8. And then we do k is equal to 5, so we have -5, or -1 to the 5 plus 1 power, 2 times 5, which is going to be 1 times 10, which is 10. Okay, and we keep going. So next is k is equal to 6, so -1 to the 6 plus 1, 2 times 6, which is -1 times 12. Oops, so -12. Then we have k is equal to 7, so we have -1 to the 7 plus 1 times 2 times 7, which is going to give me 14. And then we have k is equal to 8. We're almost there. -1 to the 8 plus 1, 2 times 8, which is -16. Then we have k is equal to 9, -1 to the 9 plus 1, times 2 times 9. So this is 1 times 18, which is 18. And then we have k is equal to 10. So that's -1 to the 10 plus 1, 2 times 10, which gives me -20. Okay, so now we need to add all of these up. So I'm going to do that here. So we have 6 plus -8 plus 10 plus -12 plus 14 plus -16 plus 18 plus -20. So if we add all these up, -2, -2, this should give us -8. So we have found the sum as k goes from 3 to 10 of -1 to the power of k plus 1 times 2k. Thank you for watching. If you have any questions, please feel free to reach out to me.